Tunnels are an interesting part of the railway infrastructure, utilised when the railway's route is blocked by geographical features such as rivers, seas, hills, mountains, or parts of the city. They are often feats of engineering in their own right. The Gotthard Base Tunnel in the Swiss Alps holds the title of the longest and deepest railway tunnel in the world at 55.7 kilometres or 34.7 miles in length and 2,300 metres in depth. The Seikan Tunnel in Japan travels 23.3 metres below sea level as it links the islands of Honshu and Hokkaido. While it's not the deepest, the Channel Tunnel, connecting the UK to France, has the longest underwater section at 37.9 kilometres or 23.5 miles. Tunnels do present some interesting challenges for the engineers tasked with the ongoing maintenance of the railway once they've been constructed. This is mainly down to the environment created within the tunnel. By virtue of being underground, conditions within the tunnel are often markedly different to those outside it, mainly in two factors: temperature and the presence of water. Both of these factors can be an issue for one component in particular: the rails. The change in temperature once you enter a tunnel mouth can be marked and rapid. It can be a hot summer's day outside, but cold within the tunnel, and vice versa. For shorter tunnels, especially where a breeze is present, the temperatures can even out, but on longer tunnels, the difference largely remains. For example, temperatures inside the Gotthard Base Tunnel, which is as deep as some mines, have been recorded at 46 degrees Celsius or 115 degrees Fahrenheit. Given they are made of metal, rails are susceptible to changes in temperature. They produce thermal forces of both expansion in the heat and contraction in the cold. A lot of time and effort is spent preparing track for and through the hotter periods of the year. For more on this, check out my video on why railway tracks buckle and the ways to prevent it. The rapid changes in ambient temperature at tunnel mouths between the outside and the inside present tricky issues for sections of rails heating up and therefore expanding at different rates. It is a prime place for a track buckle to occur. So how is this risk of buckle mitigated or removed? Through installation of adjustment switches at the tunnel extents. An adjustment switch is a break in the rail that allows the rails either side of it to expand and contract independently of each other, while maintaining a safe surface for train wheels to run on. There is another instance where temperatures of rail can be an issue. Replacement rails laid out on track waiting to be installed are free to expand and contract naturally with the changes in temperature. This is all well and good if they're going to be installed in a track of a similar temperature or installed as stress track, where they are stretched to a length they would be at higher temperatures to create tension. But when a rail is taken into a cooler tunnel and then installed straight away, that section of rail will react differently to the changes in temperatures than the rest of the rails around it. In extreme circumstances, this can lead to rail breaks. Maintenance teams avoid this by ensuring replacement rails are moved into tunnels a day or two before installing to allow them to get to the same temperature as the rails already within the tunnel. This then gives uniform thermal performance for all of the rails. When it comes to water in tunnels, there are two main issues. Firstly, tunnels tend to be damp or wet places, so water accumulates. Secondly, it can be harder to remove this water from the tunnel. Places to outfall drainage systems are limited. This is often compounded by the use of slab track within the tunnels. Slab track is a solid track construction method, where poured or precast concrete sections are used to support the rails, as opposed to the ballast and sleepers found in traditional track construction. Ballast, comprising of stone, allows water to pass through it, and can hold water itself, similar to marbles in a glass of water. The solid concrete of the slab track, whilst providing good solid support to the rails, can cause water to pool on its surface. Water and steel are not the best mix. Continuous and prolonged exposure to moisture and standing water mixed with other contaminants can lead to the corrosion of the rail, with the foot being particularly susceptible. This weakens the rail, and if not managed and removed, can lead to the failure of the rail. There are a number of things that can be done to prevent this rail corrosion. First and foremost, the tunnel should have good drainage. However, as we've already said, this can be challenging, especially in older tunnels, where installing new drainage systems is challenging to say the least. However, in new tunnels, it is a key part of the initial design. Ventilation is also a key consideration, as good airflow helps reduce humidity levels and promotes the evaporation of moisture. When it comes to the rails themselves, rails are available with protective coatings applied to them, designed to act as a barrier against moisture and other corrosive substances. They are effective, but the coating can be damaged if handled roughly or incorrectly, which does make them less effective. They can also be more expensive than a standard rail. Lastly, and most importantly, regular and thorough inspection of the rails can identify signs of corrosion. Early detection of any issues enables timely intervention and maintenance to prevent further deterioration and removal of risk. So, in summary, the two issues when it comes to rails within a tunnel is the temperature and the presence of water. Both of these can and are managed effectively by maintenance engineers around the world to keep trains running. I hope you found this video useful. If you want to know more about railway engineering, a great place to start is with our Track Components Guide ebook that is available at the link in the description below. If you want a little added extra, by signing up to our email list below, you'll get our free Guide to CAN ebook straight into your email inbox. Do drop any comments or queries below, hit that like button and subscribe so you don't miss a single video. Thank you.